Alright, so what we're going to look at today is true and false. So real quickly, I want you to look through these, pause the video, answer true or false to each of these 10 questions. If it is false, give a counterexample. Prove that it's false. Alright, go. Alright, so hopefully you get this. Let's take a look, see how you did. So we have, where'd my stupid button go? There it is. Alright. A times B plus C equals A times B plus A times C. That is true. That's just the distributive property, right? It works all the time. Birds fly. False. Not all birds fly. There is a counterexample. We can prove this is false because emus don't fly. Neither do penguins or cassowaries or anything. We just need one. Deer have antlers. This is also false because fawns don't have antlers, and neither do does most of the time. Texas is in North America. That is true. Every part of Texas is in North America. Rectangle has 4 right angles is also true. That's actually what rectangle means. From rect, right angle. It's 4 right angles. Fish live in lakes and streams. That's false. Nemo was a little clownfish. He lived in the ocean. Right? Also, some of them live in aquariums. Athletes play football is also false. Aaron runs track. Aaron's an athlete. He runs track. He doesn't play football. So that's a false statement. Geometry is a mathematics course. This is also true because all of geometry is mathematics. Humans are insects. This is false. I am not an insect. I may bug people, but I'm not an insect. And number 10, Austin, Texas is the capital of Texas, which is true. Now, if we had taken this and it just said that Austin is the capital of Texas, then we'd have to say it's false because there are other Austins. All right? I have students named Austin. They're not the capital of Texas. So that is true and false. And what we're looking at here is logic. When are things true? When are things false? If we know something, what can we conclude from that? And this is going to get us into solving geometric proofs. To start off with, we're going to talk about conditional statements. Okay. Now, a conditional statement is a statement that has 2 parts. It has a hypothesis and it has a conclusion. All right. If the conditional statement is written in if-then form, the if part is the hypothesis, the then part is the conclusion. It's not always written like that. Sometimes it's written like this with these symbols, which is read as P implies Q. Instead of if P then Q, it would be written P implies that Q is true. So, for example, we have this one. All right. If I get paid today, then I will take you to the movies. The hypothesis, the if part, is just this part right here. I get paid today. The if is not part of the hypothesis. All right. Similarly, the conclusion, then I will take you to the movies. All right. Just I will take you to the movies is the conclusion. The then is not part of that. So we could, if it was like P arrow Q, that would be I get paid today implies that I'm going to take you to the movies. All right? So that's how that works. Now, what I have down here, this is a truth table. And this is how we determine if something is true or false and all the different options. Now, for a conditional statement to be false, the hypothesis has to be true, and then the conclusion has to be false. So, for example, here, the first one, option 1. I get paid today. True. I do get paid today. Then I will take you to the movies. If that's true, if I get paid today and I take you to the movies, then we can say that this conditional statement is true. All right. Now, what if I get paid today, and that's true, I did get paid today, but I didn't take you to the movies? So this is false. Then this entire conditional statement, if I get paid today, then I will take you to the movies, is a false statement. Because we have proven, hey, that didn't happen. So it's false. What if, on the other hand, I don't get paid today? So my hypothesis is false. But I could still take you to the movies, right? Is this a true or false statement? Which one? Well, honestly, we can't make any conclusion about this statement at all. Because this says, I'm going to get paid today. And I didn't get paid today, so we don't know if this is true or not. So we're going to assume it's true. Innocent until proven guilty kind of thing. This is not a valid counterexample. It does not prove the statement false. What if I don't get paid today, but I also don't take you to the movies? I don't do either one of them. Well, then we still have to conclude that this statement is true. Because this statement says that I do get paid today, and I didn't. A similar thing, if the statement was, if I turn into a frog, then it will rain money from the sky. Well, I've never done that, and so we don't have anything to prove it's false, so as far as we know, if I ever did turn into a frog, then money would fall from the sky. All right. The hypothesis is false, so we can't make any statement about the entire thing. We can't make any kind of conclusion to that. So that's conditional statements. That's when they're true, when they're false. So real quickly, we want to look at these examples. We want to take this and write it in if-then form, and then we want to determine is this true or not. So we have all birds have feathers. To write this in if-then form, first, what is the hypothesis? What is the conclusion? Well, the hypothesis is that we have birds. The conclusion is that they're going to have feathers. So to put this in if-then form, what we have is if an animal is a bird, and animal is a bird, then and then the hypothesis, it has feathers. So is this true or false? Is it true that if an animal is a bird, then it will have feathers? Yes. As far as I know, I don't know of any birds that don't have feathers. That's part of what it takes to make it a bird, is it has to have feathers. So this is true. Any animal that is a bird does have feathers. Okay, so what about this other one? You're in Texas if you're in Houston. Now on this one, notice we've got a different order here. So the hypothesis, that's the if part. So in this case, my if is right here. So my hypothesis is that you are in Houston. The conclusion is you are in Texas. So to write this in if-then form, what we have is if you are in Houston, then you are in Texas. True or false? As far as I know, the only Houston is Houston, Texas. So I'm going to say this is true, because Houston is in Texas. There might be a Houston somewhere else, but I don't know about it. So we can say that's true. All right. Negation. To negate something means to say the opposite of what it was. Just like a -5 is the opposite of +5. So the negation of statement P, all we do is say not P. And the symbol for that is this little squiggle right here. So this not P would be written like this. So here we have. We want to write the negation of each of these statements. The ball is red. The negation of the ball is red is not the ball is blue. Because it could be pink. It could be white. It could be black. It could be anything. Only the negation is simply that the ball is not red. Right? The cat is not black. Well, the opposite of that, the negation of that, is instead of the cat not being black, the cat is black. And that would be the negation of that. And now we have all of this. Different ways of writing and rearranging our conditional statement. So our original statement is if P, then Q. If I get paid today, then I will take you to the movies. That's the original, and here's the symbol for it. That's our conditional. The converse of that, what we do there is we exchange the hypothesis and the conclusion. So if Q, then P. If I take you to the movies, then I got paid today. That's the converse. The inverse, what you do is you negate both the converse, both the hypothesis and the conclusion. So if not P, then not Q. If I did not get paid today, then I will not take you to the movies. That would be the inverse there. And the contrapositive is basically the inverse of the converse. We're going to rearrange the order, and we are also going to negate them both. So if not Q, then not P. If I do not get paid today, if I do not take you to the movies, then I did not get paid today. And that is the contrapositive. Now the thing about all of these, the contrapositive and the conditional statement will always have the same truth value. That is, that they will always be both true or both false every single time. The converse and the inverse will also always have the same truth value. They will always be both true or both false. Okay? Now, these could agree or disagree with the original statements, but these two will always have the same truth value. These two will always have the same truth value. All right? And if two statements have the same truth value, then we call them equivalent statements. All right? All right. So let's take a look at this. What we want to do here, we are going to write this statement. We have you're a guitar player, that is P, that is our hypothesis, and you're a musician is our Q, that is our conclusion. All right? So our conditional statement, what are we going to say there? We want to put this in if-then form. If, our hypothesis, you are a guitar player. If you are a guitar player, then our conclusion. In this case, our conclusion is you are a musician. So there it is. If, hypothesis, then conclusion. And in this case, is this true or false? Well, if you play guitar, then by definition, you play music, so you're a musician. All right, so this one is true. Okay, so next one. The converse. Remember what we're doing here is we are changing the orders. If Q, then P. Q implies P. So, if, what we want now is our conclusion, not the hypothesis. So, if you are a musician, then our hypothesis. So, then you are a guitar player. True or false? Well, considering my daughter is in the band, but she plays clarinet and has never even touched a guitar, this would be false. Because there are counterexamples. People who play trumpet are musicians, but they're not guitar players, necessarily. Okay, so next, the inverse. What this is not P, then not Q. So, if, and we're going to negate the hypothesis, so what we have here is if you are not a guitar player, then and now we negate the conclusion. So then, our conclusion, you are a musician, so the negation of that is you are not a musician. True or false? Well, let's see. So we need someone who's not a guitar player. My daughter's not a guitar player, but she is a musician, so that proves that this is false, because my hypothesis is true. She's not a guitar player, but my conclusion is false. She is a musician. So this is false. Okay, last one, the contrapositive. This is the inverse of the converse. So this is not Q, then not P. So if, and now we want to negate the conclusion. So we said you are a musician, and so now I'm going to say you are not a musician. If you are not a musician, then, and now we negate our original hypothesis. So it said you are a guitar player, so we say you are not a guitar player. Okay, so is this true or false? Well, let's see, we need someone who's not a musician at all. And if they're not a musician at all, do they play guitar? No, because if they play guitar, then they're a musician. So this is also true. If they are not a musician of any kind, then they don't play guitar. Notice, the conditional statement, the contrapositive, both true. The converse and the inverse, both false. These two will always agree with each other. These two will always agree with each other. Okay, that brings us to our last vocabulary term here, and that is the biconditional statement. A biconditional statement is something where the original conditional statement is true and also the converse is true, when they're both true, when they all agree with each other. Then we call it a biconditional statement. And what that usually comes out to be is if and only if. And here it is P, if and only if Q. Or here it is in symbols with the arrows going both ways. P implies Q, Q implies P. And any definition can be written as a biconditional statement. So let's take a look at that, see what that means. So here we go. We have definition. If two lines intersect to form a right angle, then they are perpendicular lines. Right? And that's true. That is the definition of perpendicular lines. So what we want to do is write this as a biconditional statement. P, if and only if Q. So our hypothesis here is two lines form a right angle, intersect to form a right angle. Our conclusion is, oops, didn't change. There we go. Our conclusion is they are perpendicular lines. Right? If, then. So the converse of this, if two lines are perpendicular lines, then the two lines intersect to form a right angle. And that's also true. So the converse and the original statement are both true, which means this is a biconditional statement. And we can write this like so. P, hypothesis, two lines intersect to form a right angle This is biconditional, so what we're going to say is if and only if they are perpendicular lines. I can't spell perpendicular. perpendicular lines. Right? And so that is a biconditional statement. This is true if and only if this is true. There's no other way for it to happen. Which means I could just as easily take this and flip it around. Two lines are perpendicular lines if and only if they intersect to form a right angle. And that is conditional statements.